The 12 Principles of Green Chemistry. 1. Prevention. It is better to prevent waste than to treat or clean up waste after it has been created. In this case, you can see a Jello packet with Jello particles inside of it, which we will call waste. Say that we accidentally spilled the waste over these two containers. One of them is covered to prevent waste and the other is not. As you can see, after the spill, one of them is full of contaminated waste, and it is very difficult to extract the waste out of the water, which may be costly and/or impossible. On the other hand, if we uncover the protection, we can see that waste has been prevented from entering in the water, thus saving product and money. Thus, it is better to prevent waste than to clean it up afterwards. 2. Atom economy. Synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product. Basically, we are trying to maximize the amount of use that a particular resource has. In this case, we have a shampoo bottle that seemingly has no more shampoo in it. However, if we add water to it, suddenly we can extract the small amounts of shampoo still left in the bottle and use it for a future shower, thus saving us money. 3. Less hazardous chemical syntheses. Whenever practicable, synthetic methods should be designed to use and generate substances that possess little or no toxicity to human health and the environment. In layman's terms, if given a choice, it is better to always use a method that is safer for the environment and for humans. In this case, one table has been washed with Clorox full of chemicals. The other one is washed with only simple soap and water. Both methods clean up table pretty well, but when a person attempts to eat off the table surface, one would rather have their mouth full of soap and water rather than chemicals. 4. Designing safer chemicals. Chemical products should be designed to affect their desired function while minimizing their toxicity. Basically, for the same problem, it is better to use a simpler product than a more complex one. In this example, we only have a mere headache. Why use Tylenol cold multi-symptom when you can use Tylenol extra strength, which has less active ingredients? 5. Safer solvents and auxiliaries. The use of auxiliary substances, solvents, separation agents should be made unnecessary wherever possible and innocuous when used. In this case, we have some chocolate ice cream. You could try to add extra cocoa powder to try to enrich the taste of the chocolate, but then you realize it has the opposite effect and is disgusting and bitter. Obviously, the cocoa powder itself is bitter and is unnecessary for this product. 6. Design for energy efficiency. Energy requirements of chemical processes should be recognized for their environmental and economic impacts and should be minimized. If possible, synthetic methods should be conducted at ambient temperature and pressure. When studying, it is best to use a single light because that is all that is necessary to read the pages of the book. Why turn on all the lights in the room? It is unnecessary and wastes energy. 7. Use of renewable feedstocks. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practicable. You could use disposable batteries, but those after one use need to be thrown in the trash. You could use rechargeable batteries and save time and money from going to the store to buy more. 8. Reduce derivatives. Unnecessary derivatization, use of blocking groups, protection, deprotection, temporary modification of physical chemical processes should be minimized or avoided if possible, because such steps require additional reagents and can generate waste. Methods that involve extraneous amounts of material should not be used whenever possible. In this case, the green jello solution is good, and we want to save as much as possible. We could try to make sure that a bag doesn't leak by putting it in another bag, then in another container, then in another bag, but that would just be unnecessary and could be costly to the project and generate waste. 9. Catalysis. Catalytic reagents, as selective as possible, are superior to stoichiometric reagents. Basically, sometimes it is better to use other material to make a process go faster rather than adding more of the original material. In this case, we could add more bread, but instead of when cooking, we could simply add more oil to raise the temperature of the pan to speed up the cooking process. 10. Design for degradation. Chemical products should be designed so that at the end of their function they break down into innocuous degradation products and do not persist in the environment. Basically, it is better to do something that produces waste products that decompose or degrade quickly and do not remain in the environment. In this case, say we're eating some clam chowder. We could use a plastic bowl or we could use a bread bowl. Even though it's obvious that you can eat the bread bowl, even if you didn't, a bread bowl would still decompose faster than a plastic and thus is less harmful to the environment if thrown away. 11. Real-time analysis for pollution prevention. Analytical methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. Basically, measurements should be taken before and during the process to ensure that there is no formation of harmful products or the process does not go awry. In this case, measuring the amount of detergent to be put in the washing machine ensures that the bubbles don't overflow during the washing process. 12. Inherently safe for chemistry for accident prevention. Substances and the form of a substance used in a chemical process should be chosen to minimize the potential for chemical accidents, including releases, explosions, and fires. In this case, we could use a match or a lighter, but as you can see, the match has the potential to burn a person's finger, while a lighter does not have this inherent risk. Both produce the same effect, but the match has a greater risk of burning your hand.